here is going to be that I'm going to get as far as I can into section 2. And I guarantee no matter what, we're not finishing it today. If you guys looked through, kind of pre-looked through the notes ahead of time, there's quite a few pages. And it's not necessarily that this topic is difficult. This topic isn't going to be difficult. It's that there's a lot of different ways that the problems can present themselves. So once you get the idea down, it's not an issue at all. These are actually by far the most straightforward and easy of the limits. So 1.3, when we get there, is going to be called analytical limits, which is doing the limits with equations, like by hand. So graphical and numeric limits are usually considered the easiest ones, but they're probably the slowest to cover, just because they can be presented a lot of ways. So I kind of relented because I doubt we'll be behind. I'll put it this way. I doubt we'll be behind because Mr. Strofer and I basically just try to plan everything so that we're about the same spot. So I know we won't be behind. What I don't want to happen is I don't want to take so long at the beginning of the year that we feel rushed at the end of the year towards the AP test. Because these topics right now aren't going to seem super simple because they're new. But as we get towards the end of the year, when the topics get a lot more difficult, I would rather go through these faster and not the harder ones. So, like I said, I want to get through 1.2 as much as I can today. And then what I'm going to do, I already lost it. Here it is. What I'm going to do is the lady that created these notes. Well, it looks like you want to watch all the Minecraft hacks on the right, huh? The lady that created these notes, she's a retired teacher. Because creating anything for calculus takes absolutely forever. Like, I'm sure you guys aren't going to realize it, but like writing a test takes me about 8 hours. And it sucks because I have to do every single test every year because calculus is so difficult. This is the class that everybody wants to cheat in. So in some way or form, I would not be shocked if a lot of you have tests from previous years. Not seeing you use them, whatever, I don't care. I'm not, but I basically have to rewrite tests all the time. So every single chapter takes me about 8 hours to write a test. Writing the actual material for the entire AP test is just ridiculous. So this lady retired, and this is what she decided to do with her retirement, was to organize all of the calc information in kind of an easier format than a textbook. And so what she did, though, is she also made a video to go with every one of these topics. And I'll eventually get to the point where I'm just going to post all of these on to Schoology. But so I thought what I would do is we'll kind of use this as an experiment. Like, this would be a good time to try this. Is we'll get as far as we can in 1.2 today, and whatever we don't finish, you guys would probably want to watch the rest of this video tomorrow during the hour. Because it seemed like a lot of you got halfway done with the homework from 1.1 or all the way done with it already from yesterday. And everybody's different, obviously, but I was pleasantly surprised a lot of you were done with the front page by the time you left here. And so you're actually pretty far into the homework. So we'll do that in class where I'll let you guys just watch the rest of the notes that we don't finish together. And then when I come back on Monday, thanks. When I come back on Monday, I want to see how it went for you. Because I'm kind of curious how this is going to feel for you. I mean, like, obviously, if I understand a topic and I watch a video on it, it'll make sense. I want to know how it works for you guys if there's something you don't know and this is fresh. Cole and Jack. Cole and Jack. Yep. Okay, in 1.2, partly, I don't know how I should say this. If you look in that sentence, it says recall from pre-calculus that you evaluated 3 types of limits. And I'm pretty positive you did not even mention the word limits last year. Okay, good. Just wanted to verify, but good. So these notes are set up that you already know what a limit is. And that's why it's going to go so much slower than what it's set up for. I brought up yesterday, I introduced what a limit is. It's a method of finding out what an answer is supposed to be when sometimes you can't directly look. So like say yesterday, last 2 days, the way that we did this was we made a table and looked at some numbers that were really close together to figure out what the answer should be if the time difference was 0. And so we basically made an educated guess. That's kind of what limits are. It's using a method to figure out an educated guess. Did you guys like having live examples?
Yeah.
Okay. Should we do this for limits?
Yes.
Okay. Let's have Let's have 5 people. Sure. Just coming up. We need 5 people in the front. Good, good, good. We've got 2, we've got 3. In fact, I need some printer paper.
Let's go stand behind us. Go. Yeah, we don't want.
Who's got nice socks? Oh, I do like those socks. Those are very flashy. Look, these are fine 5 examples. Middle person. What's your name? Maria. Maria is going to be the 0.38. I already forgot. 3.8. And then I'll reuse these the other hour. I already forgot.
Abby.
Abby. No.
Max.
Max? Excellent. I'm hoping I'm writing these big enough so you guys can read them wherever. Hate that noise. Emma. You know what? I have like 9 Emmas this trimester alone.
Yeah, it's a popular name.
Weird. Okay, so that was 3-1. Max, what were you? 2-9, so I gotta do 3-1, I guess. What did I give you, 7-9? What did I write out here, 0-1? I don't know, 8-0-9, sure. Jack. I heard Jack. Somebody cheated. They said it out loud. Okay. Well, who could have piece of paper if it's hidden behind the back? Okay, so we have these 5 people. Now, if I asked you to find f of 3, what would you tell me for f of 3? 8. Okay, how did you know to find that one? Okay, good. So to find f of 3, you looked when x was equal to 3, and you found that answer. You don't care about anything before or after 3. F of 3 is just 3. Now, we're going to talk about limits. The limit from the left. So you'll hear that phrase. The limit from the left. Well, that would be these two, because you're looking from the left-hand side. I actually don't care what happens at 3. I don't care what happens on the right-hand side of 3. I only care on the left-hand side of 3. So on the left-hand side of 3, what answer are they becoming? They are turning into 8. Now, obviously, if I had more time and more examples, we would just have a bunch of people with a bunch of numbers that are obviously turning into 8. Okay? But this is the limit from the left. Now, without saying it, this should actually work so perfect because I'm just going right on the easy guys. These guys would be the
Right.
limit from the right. So the limit from the right, you are looking on the right-hand side of 3. I don't care about 3. I don't care about the left-hand side of 3. This is the limit from the right. These answers are also obviously becoming 8. So then what we're going to run into, without rolling over any toes, if I ask you to find f of 3, do you remember what to do? What do you do? F of 3. Looks like you already forgot. You remembered when I asked you before I said anything about limits. F of 3, what do?
Look where x is 3.
You just look at 3 and you don't care about anything else. Good. F of 3. I already forgot.
8.
No, name. Maria?
Yeah.
Maria. Maria is f of 3. That's all we would use Maria for. Okay? If I ask you to find the limit from the left, what would you use? Only these two. If I ask you for the limit from the right, only those two. The one that seems confusing even though it shouldn't be. Most of the time, you're not going to be asked from the left or right. You're just going to be asked, what is the limit as x approaches 3? So that's going to be called a two-sided limit. So if you're just asked for the limit, you look on both sides. You do not look at Maria. The word limit means outside of it only. Maria would only be f of 3. And in fact, we're going to have quite a few equations where the function value in the middle is not even there. It's like a hole. And if I ask you to find the limit, these two sides, actually, tuck down, perfect. These two sides have to be the same. If I ask you for the limit as x approaches 3, these two sides have to be the exact same. And they both have an answer of 8. And so the limit as x approaches 3 is 8. The left-hand limit is 8, the right-hand limit is 8, the two-sided limit is 8, and then f of 3, the middle, is 8. F of 3 has nothing to do with the limits. The limits have nothing to do with the function value. They can be the same, they don't have to be. They are three separate things. Now, if you can get that part straight, the limits, the whole limit thing is going to be relatively straightforward. And that's by far the hardest part that everybody has, is keeping the info straight. I'm hoping this helped. This actually seemed pretty good. This went really well. Did that sort of make sense? I know we haven't had any problems yet, so it's really hard for you to answer probably, but very nice job on exams too. I mean, it was very difficult for you to examine there. Okay, nice. Okay, I'll collect these because I'll definitely use these again. Nice, nice, nice.
So like on a graph, as it approaches 3, is that when it would like?
You just look before and after only. Whatever happens before and after 3 is what you look at. I think, did you start homework early?
No.
Oh, okay,
I'm just thinking ahead.
got it. Okay, the notation, you haven't seen any of the notation yet. And that's why I wanted to do that example before I talked about notation, because the notation is, yeah. A right-hand limit. It will be written like this. Yep. A left-hand limit will be written like this.
Or what's like the arrow mean?
That was a horrible arrow.
Arrow CT.
That's C plus.
Oh.
This is C minus. C plus.
Gotta make your pluses more clear.
Can't do it. How would I make a plus clearer?
Make it
Make it
small.
more
Just make it
even.
small.
Because right now it looks like a T because you have it moved up a little bit.
Hey, I thought it was a plus.
I do not.
I thought it was C to T.
I thought it was like C.
Thank you, that's so much better.
I was like,
That is
I'm glad that I erased millimeters of that.
No, that's good now, yeah.
Yeah, right.
That's way better.
Mhm, mhm. That's the notation that you're going to see for limits. From the right, from the left, this means from both sides.
What is the f of x doing? Is it just like floating there? Is it trying to be one of the cool kids? What's it doing? I don't understand what it's doing there. Is it like, how does it fit? I guess I need to see it like on a calculator or in an equation.
This is f of x.
Right, but like, how is it supposed to look in the equation?
There.
That doesn't look right to me.
It's just in line with the limit.
That's just the way it's written. I don't know.
Okay, thank you.
Doesn't have to look right, that's just how it's written.
Okay, thank you, Maria.
What did you say differently?
It's on the next page.
I know I work magic.
Oh, I didn't leave enough space. Now, I've said this aloud a few times. But the way that you read this off, the limit of the function as x approaches c. Let's pretend I didn't write left. Did I say left out loud? Why would you put right before left? Uh-oh. I honestly, I didn't even notice. I have the symbols written correctly. The right-hand side is a plus, the left is a minus. So I don't know if you've thought about it or figured out the plus or minus part yet. If you think about a number line, positive or adding, whatever you want to say, is to the right. On a number line, negatives are to the left. So this follows like number line directions, I guess. Now, do I need to write that one? Probably not.
No.
It's the exact same thing except the word left. And this is the exact same thing except you don't have from the right or from the left. This is the limit of f of x as x approaches c. And the general limit is traditionally the more common one. So if you just see a limit, it automatically means from both sides.
But wait, if it says that, you write both time, right? You do more work then if it's general?
Yeah, you actually do, you definitely do.
Why limits? Like, why limits? Like,
Are you asking WHY or like
why as the like,
letter?
yeah, like, you know, it's like X, Y.
Yes, a limit is a height. That's what you're asking.
Yeah.
Yep, correct. A limit is the height of the function. So when you're asked to find a limit, you're asked to find a height that may or may not be there, but it's just a different way of asking for a height rather than a function.
Two things. I think what she was asking was, is there X limits? Because if it's height, then is there length limits? Right? That's what you were asking. Which one you was asking?
No, she was just confirming her own thought, I think. But if so, this would say a Y instead.
Gotcha. And also, if you do the general limit, you just find the right limit and the left limit and take the average?
Oh wait, no, I'm sorry. You threw me off there at the end. You do not take the average.
Okay, how do you find, I'm not sure I understand how.
The two-sided limit is when the left and the right are identical.
Okay, so it can only be when they're identical.
Yes.
Okay.
Yeah, you don't average them.
Wait, so if you're doing the two-sided limit, you only really have to find one side because they're the same.
If they're not identical, it's
Okay, I don't know.
100% not. That's why there's a lot of notes, because they can look very different, like, there's a lot of different situations.
Okay.
If they're not identical, is there no general limit?
Correct. You would answer no limit. Okay, well, we'll start to get to example one now. Which time do we get done? 44, all right. Yep, guaranteed we are not finishing. Okay, we are going to do this one together. What am I hearing?
That was my chair.
Oh, really?
It's squeaky.
Oh, it sounded like some sort of a beep, like alarm, and I was worried it was somebody's like diabetes monitor or something like. Okay, now this has a lot of information written. I don't care about a lot of this information. I mean, like, I do care about this information, but my focus right now is on limits. So let's say we have this function. The goal of this question, so ignore this for now. The goal of this question, what would be the limit of 3x squared minus 8x minus 3 over x squared minus 9 as x approaches 3? Now, the reason this question would be asked is because if I asked you to find f of 3, what would your answer be? There does exist. There is no f of 3, because f of 3 would give you 0 over 0. At x equals 3, there's a hole. Right? So if you were asked to find f of 3, there's nothing. So in situations like this, we would frequently use a limit to find what the answer should be. Okay? Now, when we're trying to find a limit, this one is a two-sided limit because it does not say plus or minus. The way that you find a two-sided limit is by looking at the minus and the plus. And if they are the same, then automatically the two-sided limit is that. And it only works if they're the same. Okay, so we'll get to this stuff, but not yet. What would be the limit as the function approaches 3 from the left. And then what would be the limit as the function approaches 3 from the right? That's what our focus is, to find the two-sided limit. How do I determine the limit from the left? What did we do for the people? We just looked on the left-hand side, right? And we looked at their answers. So what I'm gonna do, this is x equals 3. I'm going to look on the left-hand side of 3, and I'm going to look to see what the height is. On the left-hand side of 3, why is it such a bad answer? Why didn't they pick a nice easy one? I have it written down, I'm just gonna use it. Why did they choose that one? That is the height 5/3. That is horrible. Okay, so this is the height 5/3 or 1 2/3. So on the left-hand side of it, I can tell that it is pointing towards that hole. So on the left-hand side, the height is turning into that height. So from the left, 5/3. We're just gonna pretend we knew that was the height 5/3. From the right, same thing except it's pointing downwards. But from the right-hand side, you can tell that it's pointing towards that hole. And currently that hole is at a height of 5/3. Now, you don't have to use a limit on a hole. But frequently that's where they do, because you can't find that answer otherwise. You could technically find a limit anywhere. We could find the limit as x approaches 0. But that one's easy because I can just plug 0 in and get an answer.
Where's the 5 coming from?
5.
5/3.
Oh, we're gonna pretend that we knew that that was the answer.
So like to get that answer, you would plug the 3 into 5/3.
You can't,
Oh, okay.
because if I plug 3 in, I get 0 divided by 0.
Guys, we're learning how to be con artists, pretending we know how to do math. So just
Yeah.
chill
Is
out.
it, is the limits always, oh, yeah.
So to get the 5/3, you just plug in like 2.99 and then like assume it was 5/3? Like as you got closer to 5.
I'll take that as a yes. That is how you would do it for now. That's how you would do it for now. The real way to do it, if that's kind of what you're asking, we haven't been taught this yet. The real way to do it is to factor those. And then x minus 3 would cancel. And then the equation that would be remaining, you would be able to plug 3 in and get 5/3 as an answer. That would be the real way. That's gonna be called an analytical limit, which is the next section. So this is, the reason I was annoyed is because we're supposed to have graphs that are easy to tell points for right now. This one's not. How, everybody else, ask away if something is not clicking. Yes?
And then that top part of the graph, are we just ignoring that for now?
This part?
Yeah.
We're ignoring it because it has nothing to do with what I was looking for. You only look where you're being asked for.
Okay.
Yeah, that's why I didn't want to answer this stuff, because to me, that would bring your focus off what we're trying to talk about.
So will we still factor?
You don't know how to do it yet.
So you said we only look where it's asking us to, how do you know where it's asking us to look?
The number that's in that spot is where you're being told to look.
So will there always be like a dot for us there, or will it always be a line sometimes?
Anything and everything. The graph will always be different.
Okay, okay, so how did you know it was exactly 5/3, or like 1 point, whatever it was?
I looked at the picture.
Well, I would not be able to determine that, I would like,
I agree. I cheated. I looked at the answer.
so how would I do that?
You're gonna get better pictures.
Yeah, you're gonna better.
You'll have a picture where you'll be able to tell the height.
Why is the F of X so high?
That's definitely a good question. It's probably something I usually just overlook. We traditionally write points in previous classes as X, Y. Right? But we start using function notation a lot more now. So rather than calling something Y, we just call it F of X.
Oh, okay.
So F of, like when you write out equations, you'll see sometimes it'll be written as Y equals. Otherwise, sometimes it's written as F of X equals. So if it has function notation, use that instead of a Y. Should we move on?
Yeah.
Okay.
No, I think we should all take a nap.
Well, I will be taking a nap, but just not now.
Sleep deprived teenagers, we need designated. I'm not suicide, I'm just, like, what time is it? That's the earliest I've been to bed. And I'm still tired.
I don't know how to get this whole thing on the. Oh, way too small. Is that big enough at all? I suppose it doesn't have to be big enough because you have the packet in front of you. Okay, so let's try to do these 6 together, and my guess is that's all the farther we'll get. So we're just talking about visual, graphical limits. I think you guys will be pretty good at table limits because we've been working with tables already. Those first 2 days that we talked about finding instantaneous rate of change, that was a table. So the second half of this section is finding limits by using tables, which we actually already have, but we called it differently. We called it instantaneous rate of change instead. You're just trying to find the answer or the top of the fraction kind of from the table. Okay, so up here, this is the exact same picture. As x approaches negative infinity, who should we go with? I want to call somebody who hasn't called on yet. Somebody who hasn't called on yet. I want to involve everybody.
Call in the football players.
They've participated every day. Hayden, you've done a very good job of staying invisible back there. So, this first box, as x approaches negative infinity, what does that mean? What is that telling us to do? Where is that telling us to look? What does x being negative infinity mean? Perfect. This means the left-hand side of the graph. Graph. Okay, so on the left-hand side of this graph, f of x meaning, what is the height of the graph on the left-hand side? So it looks like it is, wait, it's 3/5. Did you mean 5/3?
Yeah.
Okay, that's only that whole, actually. So as the graph is going towards the left, it is going to turn into that dotted line, which is the horizontal asymptote. Now, every graph is different, but on this one, the farther you go to the left, the more it's turning into that. So that looks like it is a height of 3.
Yeah, will there always be,
So for part of the, negative side of the graph, there is nothing there, if that makes sense.
The bottom?
No, like between the two lines.
Oh, right at x equals -3. The vertical asymptote.
Okay.
There's nothing directly on the vertical asymptote. But the graph would go up to it on both sides. But correct, there is nothing directly on -3, but I think that's a different question.
Okay.
will the graphs always give us the asymptotes? The dotted line?
Not every graph is even gonna have them.
Oh, okay.
And generally, it's just something you'll be able to spot pretty easy. Because if it has a vertical asymptote, your graph kind of has to curve to follow it. So you'll be able to spot them pretty easy. They're not always gonna be labeled dotted lines though, but you'll be able to figure it out from the equation. I think that's what you're asking. No, you're just fixing your hair, all right.
Yep.
As x approaches infinity, so the right-hand side, it's going to be the exact same 3. As x approaches -3 from the right. Okay, so now we're going into detailed words. So, as x approaches -3 is right there. When it asks you to look from the right, that means I'm going to look at -3, and on the right-hand side of -3, that's right here. That's the right-hand side of -3. And it's asking what kind of answer is it turning into. And since it is pointing downwards, that means it's going to have a height of negative. Let's pretend that did not happen. Negative infinity. As x approaches 3 from the left, okay, so now this is actually what we did on the previous page. So x approaches 3, 3 is the whole. So on the left-hand side of 3, it's a height of 5/3. And I'm kind of taking my time to go through this because I know over the past years, this feels confusing even though you're not really doing much. You're just like looking at a picture. This feels confusing because so much of the words and the info is the same. Okay, as x approaches -3 from the left. Okay, let me change color so it's kind of color coordinated. So -3 from the left, that would be right here. So
Positive infinity.
I'm approaching -3, which is that dotted line on the left-hand side going upwards, correct. Positive infinity. I was gonna write positive 8 just for fun, but I didn't. As x approaches 3 from the right, okay, so then that's this hole again, and then from the right, that way. So from the right, it is also at a height of 5/3. Now, what's gonna happen this whole year is you're going to have lots of things like this that are generally going to feel confusing until you get the terminologies and everything straight.
Is that always gonna be the same, the left and the right?
No.
How do you know?
I want to say it is on a coming up page, this page, the very next page. So if you look at the very next page, you're going to have graphs that are just random things. Are you yelling at this picture?
What?
This picture?
No,
Oh, okay. Future section? Yeah, it looks, don't look in the future. If you look too far ahead, it looks really bad. What should we call that? Leo! Leo, you have also done a very good job of just blending in back there. It's weird how the back row tries to just go in the back and blend. Do you think you could help me with A? F of 2. Do you remember what to do on function notation?
F of 2.
If not, Maria can help you because she was the function notation.
You want me to write it in function notation?
The answer to all of these is going to be a single number.
Okay.
So it doesn't have to be written in function notation. I just need to know what to do to find the answer.
So,
How do you find f of 2?
so you go to 2,
Yep. I know, it sounds stupid, but you're right.
-1.
It's okay. So you went to x equals 2, and the height at x equals 2 is -1. Okay? How come not up there? But you're correct.
Because it's an open circle.
Perfect. Open circle means it's not there. So if I go to x equals 2, the height is -1. Okay? And then we only have a couple minutes, so I'll just kind of skip to some of these. You guys are doing great. Once you figure out the graph ones, they're free points, you know. The limit as x approaches 4 minus. Leo, you call on the next person.
Luke. Which one?
Boy, you go way out of your comfort zone here. Okay, ready?
Yeah.
What does the 4 minus mean?
It means it's approaching 4 from the left.
Perfect words, perfect words. This means approaching 4 from the left. Say it again. Luke, did you have a question?
Yeah, 4 on, like on the x-axis?
Correct, correct. So I'm gonna go to x equals 4, and here's x equals 4. On the left-hand side of it, it is right here. So it is going to a height of 3. Now, I'm just gonna skip to the one that I know you'll need to see, which is going to be the limit as x approaches 2, k. Let's go straight to k. If I'm looking at k, it does not have a minus or a plus, which means it's both sides. So if I'm looking at both sides of x equals 2, they have different answers. From the left has a height of -1. From the right has a height of 1. Because the heights are different, this has no limit. It has a limit on each side, but because their answers are different, it's not a two-sided limit. How's that? Any kind of, yes, go ahead.
For B, it would just be no answer, correct?
F of -1, no, f of -1 would be 4.
Oh, I didn't see that up there. You're right.
Oh, yeah, otherwise, yes, otherwise it'd be no answer. You could say no answer, otherwise you could say indeterminate, doesn't exist. There's lots of phrases. I don't know how this lady phrases it. Okay. I would watch the rest of that video for you guys to figure out how to do limits from a table. But I think you kind of already know.